tell that to NASA. Originally, it was 4, with the idea that, it was all designed around an Earth-Sun analog. We'll be really happy if we can find one Earth-Sun analog. No. Erase that. We'll be really happy if we can find like 50 Earth-Sun analogs. In order to do that, you need to detect at least 3 transits so that you can get the periodicity unambiguously. And so for the Earth-Sun, that's an orbital period of 1 year, so you need at least 3 years, 4, depending on how it's phased up. So we originally proposed for 4 years, and then we got de-scoped. NASA cut the budget, and we de-scoped down to 3.5. There are consumables on board that we've got a limited amount of fuel, and so the projections are looking like we could last another 10 years with regards to the fuel source. However, the Kepler spacecraft, it's not orbiting the Earth like the Hubble Space Telescope. It's actually orbiting the Sun. So we sent it away from the Earth's gravitational claws, but it's gradually drifting away from us. So we're losing bandwidth. It's taking longer and longer to get down the same volume of data as the years go by. And eventually, all we have to do is just de-scope, decrease the number of stars that we're sending back down. We could easily go another 6 years, let's say. And we're trying to make that happen. Yes?
So are these all single stars? Could you see planets around binary stars?
They're not all single. We have a catalog of eclipsing binary stars that we've created now, and it's got about 2,200 eclipsing binary stars in it. And there's a group of people, a working group, who looks at those light curves to see if there's any indication of a planet signature in that system as well. So it's possible. You have to look at the dynamics and see where things are stable, and depends on the separations and all that, but it's possible, yeah. Yes?
So what does Earth-like mean to you exactly?
Did I say Earth-like?
No, you didn't. But
I was very careful, I think, not to say Earth-like.
I'm just curious what you think it means when you define it in terms of orbital parameters, in terms of atmospheres or liquid water, or what?
We can't use the word like in our publications. I'm a scientist, I'm sorry, my brain will explode. I can't parse your question. Earth-like is a planet that has butterflies and flowers, I don't know, has lattes. I don't know. We're very careful. We say Earth size because what we're actually measuring is size. In the habitable zone, out of the habitable. We don't even say. I try to be very careful of saying that this is a habitable world. It's a potentially habitable world. The fact that it's in the habitable zone says nothing, right? Yeah. I'm sorry. I know I didn't answer your question to your satisfaction. Yes.
The field of view that you're looking at, is it extending across the whole galaxy, or is it local?
It's a very relatively speaking, considering the scale of our galaxy, it's very localized. We're looking out at stars out to maybe about 3,000 light years. Galaxies like 100,000 light years across, so it's very much the solar neighborhood. But after we determine how abundant Earth-sized planets are in our galaxy, the next step would be to design an experiment which would find all of those that are within, 50 light years, all those that are closest to us, 100 light years, That's what we really want to know. Yes, in the front.
How do you know since there's so many stars in the field? How are you sure that it tells us which one to directly
So the telescope, the array looks something like this. It has those corners that are notched out, and there's a fine guidance sensor in each of the corners that's tracking certain stars. And that's actually very, very important. We could not achieve this precision if we didn't have exquisitely accurate pointing. You don't want those stars to move inside of 1 pixel very much because the sensitivity curve inside of a pixel to how well it measures brightness there's a strong dependence there. You want them to stay very stable on your detector. Yes?
This whole system depends on the finality of the system.
Yeah.
In quick passing sub-statement, what fraction of the orbit is essentially expected to be planned? What was that number?
For an Earth, so the probability is proportional to the distance between the star and the planet, and divided by the radius of the star itself. So let's see, if the radius of the star is larger, the probability of alignment is larger, and if it's farther away, the probability goes down. So it's the inverse of that, the radius over A. So for an Earth-Sun system, the probability is about 0.5%. For a planet that is in like a 1 or 3 day orbit, very close in, it's about 10%. Yes?
Density of 8 seems high for
I'm sorry, the density of...
density
oh,